Okay, it looks like we're starting. Let me make sure chat works. Hello, world. Okay, chat's up and going, stream's up and going, audio's up and going. Check, check, check. Let us do a stream. So this stream's gonna be a little bit more relaxed than my normal streams. We're gonna try to take a design I did for the Arty board and port it over to the Artix UltraScale Plus board. I got the Opal Kelly PMOD, and I have a lot of PMOD interfaces, but the one I'm interested in getting running is the DVI over HDMI one. So we have the HDMI card right here sticking out of this board, and we're gonna just do a simple VDMA core with the MicroBlaze and try to get a screen running. I don't actually have this plugged into anything, so we'll have to figure that out somehow. I'll maybe plug into this monitor over here that none of you can see, but we'll get something running, and if I can capture it, then we'll look at doing some capturing with it. But for now, we're just going to see if we can get it up and running, and then we'll plug it in later. Oh, does that monitor have HDMI? It does not. Okay, we'll have to try that one, or this one, or something like that. Okay, so let's get started. So to begin, let's look at the previous design. So the previous design has a MicroBlaze and and then the DDR, right? And what's happening is we're storing a frame of video in the DDR, and then we have the VDMA core is reading and writing, or is this just writing? Yeah, it's just a read channel. Just has a single read channel that is then being outputted to this. We're doing 24 bits. We're only sending 4 bits out. We should go look at that core. So this is packing 32 bits into 24 bits so that we can keep it tight. We go look at the software for this. Look at the software for, what's this, DVI2, the SDK, hello, source. What were we looking for? We're looking for the packing, how we do the image. So right here is where we do the image. Okay, yeah, we're packing it in pretty tight, so we can do better transfers. Or maybe argued either way. So VDMA outputs the image here. We unpack it. We have a simple filter operator that has a kernel attached to it, and then we send it to our DVI stream, which is a custom core. So we can go open this up, edit an IP packager, and see what this is doing. Let us go. So we're dropping the data, right? Because we're getting pixel data is coming in only at 12 bits. So how are we doing the pixel data? Where's pixel data coming from? Pixel data, pixel in. Pixel in is coming from here. Stream FIFO. Oh, made it. Where is FIFO in coming from? Oh, okay, FIFO in, we're grabbing the top bits of the color. So we're only doing 12-bit color here, not 24-bit color. Oops. Okay. What did I do? Oh. Did I screw it up? Let's go open it again. I might have broke it. What did I do to it? Okay, so now we're gonna go try to do this on the Artix UltraScale Plus board. Okay, seems fine. I don't know why. But that's okay. The same, I promise. Sure. Okay, we'll upgrade it. So let's go open up the new Vivado and start working on getting something. Getting this working with our system. Yeah, we don't need cache memory. Okay, so we're gonna create a project. An IBA. We're gonna call it DVI. Killed myself here. Okay. So DVI 00. So yeah, we're going to towards Opal Kelly. Oh no, this is a bad idea. Not supposed to do this during the stream. Oh well. We'll let it go. Hopefully it's not too slow. Supposed to have the board data, right? I guess I could do it from scratch. Why don't they have it? No, it's there. Ugh. Think of the right one? I did the right platform. Okay, maybe we'll just open another one. Grab something that was using it. Did they update the... Can't find the board files right now. I wonder if GitHub Xilinx board store. Was there a recent update to 2020.2? Yeah, so that was nothing new. Okay, yeah, you have the project part here, so we're just going to save as for some reason because I can't find the other one. We're gonna call it DVI 00. Okay, let's open pop. Where are these different? Oh, this is the partial reconfiguration. Um, yeah. Let's go ahead and just delete our xdev config. Delete our ports we don't need. Okay. Here, megahertz. That. System ILA. Don't need to, here debug. Okay, that should be good to start off with. And let us delete these two. Remove file from project. Also delete it. Yes. And our top wrapper is also probably garbage at the moment, so let's go do that real quick. Okay, so now let's we're going to want to copy over the IP that the DVI board was using, right? So stream, so let's go to that IP, right? So this has the pack, so we want these two. U2P, new folder DVI IP. Whoop. You may need to redo the kernel unpacking. We'll see. Yeah, it may not work. But we can open it up with software and regenerate it, or just open a new one. I do a new folder of HLS V2021. Okay, let's try to get this repo up to date. Ignore valid top. So let's go to IP catalog and add repository, DVI IP. So we're going to want to open that project. Okay. What's the best way to go about this? Probably just try to go to the new flow and see how that works. What are you upset about? Oh, are we not connected to a clock? No, that's not good. We should, yeah, connect everything to that clock. Oh, we should probably do a new clocking wizard. We'll worry about that later. So let's go. Let's go create and package a new IP. So, oh really? I don't want to do. I want to create an IP. Oh, why is this being so annoying? Let's open up another project real quick that is the same flavor. Let's open one of the camera ones. Looks like we're losing some frames sometimes. Okay, let's go ahead and try to create a IP. We're going to create a new peripheral, and it's going to be in DVI IP. Right, that's the folder we made, DVI IP. It's going to be called DVI stream, 12-bit RGB to DVI output. IP XEM. We'll call it XEM IP. Okay, so we're going to want Axelite. How many registers? How many register bits did we have on that one? Good question. 64. Let's open it up and see. How many registers actually address width? 7. How many did we actually care about? Okay, 32 registers. Do that. 32 registers. 32 registers. Data width, slave, light. And what was the port name? It's called, yeah. Yep. We're gonna call this one S. We're gonna make this one stream. I'm gonna do this. S00 XC S00 light 32. Okay, make this a stream. There we go. Yeah. That's what we want. We're gonna edit the IP immediately and just see if we can add the files. Oh, this is Verilog. I'm gonna do VHDL. Okay, so we're gonna go back to project. Always make this VHDL so I can copy and paste those files easily. Cancel, apply. Okay, let's try this again. This is the one we want. Ooh. This is gonna be a slow stream. Oh well. Okay, let's try again. DVI stream DVI IP slash stream IP override existing. There we go. Okay, they fixed that issue. Stream 32, yeah. No, it's gonna be 24. What did this one do? That's okay. Next. Edit IP. Okay. So yeah, I guess we probably could just see what that file looks like. Have they dramatically changed anything? No, so I say we just copy and paste. Let's just do it the quick way. So we're gonna copy this one here. Okay, good. They haven't really changed this very well much. Right here. Okay, now let's grab. We want to add files, add sources, assign sources, add files. Up, up. One more. Stream. Oh, no, the IP section. IP repo, DVI source. We want HDL, we want that guy. I think I just add the which one do you want? I want the stream FIFO. So adding that one. Source stream FIFO. That should be it. That was weird. Okay, so you'll add one at a time, I guess. Oh, it's saying. Did I just do something bad? I think something bad. Oh well. So now we're gonna add the XCI file. The report IP status. Okay, upgrade selected. Yeah, sure. Okay, so let's run synthesis to make sure still happy, but we should have it good to go. drop that down, hook it up, and see if we can get something working. We'll have to fix the unpack one. But we can do that real quick by stealing some stuff. So let's get the, while this is working, let's get the HLS up and going. And we're going to just copy a file. Actually, let's go ahead and download it. The pink GitHub. Let's go to boards, IP, HLS, pixel unpack. That'd be, you want, I think we just need a CPP. Well, we'll grab both of these. So let's grab both of these and add them as sources. We want to say raw, hit save. And then we want to hit raw and save. Yep. Okay, and then should we then probably go put those in a safe place? Put those here for now. Okay, that was good. So let's package this back up, file groups. That looks good. Okay, so now if we go back to DVI and go back to the IP catalog and refresh all catalogs. So A25P, DVI, IP. Is that not? Oh, there we go. Add IP to IP block. Okay, let's get the other one going. So HLS core, where'd you go? Here we go. HLS, we're gonna create a project, and you have no apps. Xsub AU25E. Yep. DVI IP, the folder. HLS v221. HLS v221. Project name is going to be pixel unpack. Next. Add files. Open. Browse. Pixel unpack. Yep. Next. Don't need test benches. We want the XCAU. AU25 2E. 10, that would be good. I don't think we're going above we probably want to go this higher. We'll do 10 for now. Okay, so let's go ahead and run the synthesis solution for the active. And should just run out of the box. And then we can add that to our, we should probably add the VDMA core while we're here. Go ahead and add VDMA. Run connection automation. Oh, that's first. Guess we'll do. How many does the other one have? Let's be picky. Diagram, VDMA. Yeah, just one frame buffer. Anything interesting in the advanced tab actually? Nope, not really. One frame buffer. Or front settings. Sure. We'll follow those. 28, 56, 32, 1024. Advanced. Okay. Yeah, we should get a clock. Is that a clocking wizard? And we'll set it to, what was our main pixel clock here? Coming from this guy. He is outputting a 74.25 probably for 30 frames. So 74.25, let's go and do that. Actually, we're going to take our U clock, get in there, and validate. Okay. Clocking options. Output clock is going to be 74.25. No reset. A run connection. Pixel clock. Yes. 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 Go ahead and do all the clocks real quick. And this is going to the DDR. That's going to MicroBlaze. Figure out the other things later. How's we doing here? Looks great. Yeah, looks like I can do great. So we're going to do implementation. And I think we just go back to our system right here, and back to the IP catalog. We're gonna add a repository. Okay. Okay. Oh, what is this? Oh, must have not been happy with a setting. That's a weird issue. Let's just export it. Export RTL. We'll create a zip output location. We're gonna just do it right here. Like folder. Vendor AEW library pixel version 1.0.0 pixel unpack. And we'll just extract that to back. And then we'll go back here and we'll do a refresh all repositories. Do we not have the right board? 25 EV, FVB, FVB 6762E. Why won't you let me add this IP? Refresh all repositories. Oh, why did we not work? Why, oh why, oh why? XEM8320 FFBB2E. Okay, I'm not seeing a good reason why it's not working. Why are you not working? Okay, I guess we'll go try the part. Apparently we didn't pick the right part. Synthesis. No. Solution settings. Synthesis. Apparently we need to go to family. Make sure we're on the oh, we're in the wrong HLS. That's right. Okay, exit. Vivado 2022.2 HLS. Vivado, oh no, it's Vitus, right? Vitus HLS. Okay, well, we have the files. We can recreate it relatively quickly. So we're gonna delete that. Let's create a new project. This location. 25p DVI IP HLSV 2021, and we'll call it Pixel Unpack. Next. Files. Files. Functions. Next. You want the the XEAU25E. You want the 2E B grade 2 grade E. FFB, yeah, want that one. Yeah, finish. So we'll create it, export it, and get this, see if we can get this built quickly. Okay, so solution, run active solution. Oh, we should probably start working on the, I don't like Intel unpack, so we're gonna do this. Create the top level, create the software. Oh, I forgot the header king over there. Cool. So we're gonna go solution, export RTL. Version 1.0.0. Pixel unpack. Okay. Now we go to DVI and we hit refresh all repositories. Yes, we have it. Made it with the right software, right? Yeah, it's the right software. Do I need to like be very specific in this family says 2E not the same part. What were the other ones that we did? So this one works for that product. What's happening? Why can't I add it? That's so weird. If we add repository, right, and we go and we're like, oh, we did HLS in this video kernel library, right? Can I view their compatible families, like properties? Like, yeah. How do you know the difference? Vivado probably has it. It does have a dark mode. Using it though. Play. Colors. Oh. I think you have to do it yourself. Um. What's different about these cores that when I hit solution port RTL? Why does this magically work and the other ones don't? Ah! Okay, whatever. We're just gonna try a new project. Why? We're gonna try in video kernel, right? We're gonna be HLS projects. Select folder. Select pixel. Unpack. Next. Next. Family. What we want. We want Artix UltraScale. We're gonna do that one, 2, E, and the 25. Yep. And move those files over, I guess, to where video kernel projects source new folder source. Add them to the source folder. Source, add source file. Solution settings, synthesis, project settings, synthesis, pick a function. Okay. We're just going to run active solution. Okay, and then we're just gonna do implementation. Yeah, just hit OK. There's. We're gonna go to DVI. We need to kill that one. So let's go to back to DVI IP. Refresh all repositories. And we're going to add a repository. This is just going to be the implementation folder. Okay, it doesn't even see it, so let's go ahead. Oh, I didn't like it. So we're going to export the RTL. The repo, select folder, DW, pixel 1.0.0, up, on pixel, unpack, right? Can this be done, or is this just more annoying stuff that's being an issue? And rename pixel unpack. Refresh our repository. Cool, finally got it working. Was more annoying than I wished it was. You are going okay. Run a connection automation. This is all running at the same clock, we're fine. Do we have to do this whole annoying thing where we don't really care? How did I do it here? Like, there we go. Okay, what we got here? Yeah, sounds good. Yep, sounds good. Okay, let's validate it. Let's get the address map to line up. DDR should be at 800. VDMA should be 4480. VDMA is 4480. DVI should be 4481. Yep. And pixel unpack. Pixel unpack. Oh. You didn't even connect it? Wow, that's bold of you. We'll just connect it. Was it not in the software at all? Address. Oh, we don't have a UART in this situation. Yeah, we'll just assign it. So, we'll do 4. Okay. Smartest thing in the world. Okay, validate. We never really looked at what the old one was doing. Let's go do that real quick. Yeah, it's the same code. Okay, so that's good. So yeah, let's save this and create a wrapper. Create HDL wrapper. Okay, so we need a reset. So const 0, IP const value of 0, and let's plug that in here. Validate design. Let's do synthesis, and then we can do pinout. That's fine. That's the only thing we should see. Let's run a synthesis. Ooh. While that's going, let's look at our pinout. So we're gonna want, this is all going to be port D. So we're gonna want these ones. Port D right there. Okay, and we're gonna want PMOD. It's gonna be the second two PMODs, right? PMOD 3 and 4. So that's PMOD 3, that's PMOD 4. So we'll probably start with I guess 4. So this one? Yes. Okay, PMOD 4 is so 1 is it's gonna be 36. So 36. Port 36 on this PMOD is going to be pod 4 1. Pod 4 2. So it's just gonna be like 3 4. And then we're gonna go back to 35 right here, and it's gonna be 7 7 8 9 and 10. And 1 is going to be, PMOD 3 is going to be actually all the way up at 6. Wow. But it's starting at 12. 12 is 1. 2. 3. 4, 5, 6, 7. Oh no, go straight to 7, 8, 9. Okay. So then we just gotta get the ports for it. Okay. Grab these ones. And then grab the ones we want down here, which are these ones. What does it look like on our old constraint file? Sources, constraints. So this is what it'll need to look like. Okay. So first pin is going to be R3. And so we're going to start here. It's going to be R3, R3. And then 7, which is right below it, is going to be 2. This one's going to be R1. And then this one will be R0. What do we have next? Next are the greens. One, 0, 0. And I assume, okay, next we're going to do blues. Same pattern. What we got next? Oh, no, this is CK. So it goes B3, B2, CK. So this is CK. So this is actually 1. This is 0. And let's see what does our output port look like for that. Top wrapper. Green, red. How do we have the clock exiting this one? Did we miss that? Oh, and we just have the clock exiting. Cool. This clock needs to go out. Okay, so we're gonna need a that's good. We're gonna add a straight port. It's gonna be an output. It's gonna be a clock output. Pixel clock it. Probably do like a proper. Oh, it probably will do a proper clock. Okay, so let's validate it. Generate it. The names. Oh, the names can be garbage. That's okay. We can deal with that. Run synthesis save. So this one right here is going to be pixel clock 0. Okay. Let's update the names real quick. Replace blue underscore 0. Replace all. Red. Red. It's all green. Green. Replace all. Okay, cool. So what do we have next in our ports? And then we're going to be, after B0, it's going to be DE, which has to be active. And then be H-sync. And then V-sync. All the other ones, it's going to have a cancel. We're just going to add that to a constraint file. Okay, that seems good. Do we have a constraint file here? I do need to set this to 33. And then we should be able to rely on, what clock is this using? It's using a custom clock. So that custom clock is going to be in here somewhere. Okay. We're not doing a P block, so get rid of that. What's the clock name? CDR 100 megahertz. Okay. Keep that. Oh, let's go over here real quick in the LVC MOS 333. Be too many to go through. Okay, cool. The synthesis, yeah, it goes out of date. Let's run synthesis. And then we should get the software up and running pretty quickly. Let's see how that works. Okay, so this works well. Then we can export it without the bit file and then get the Vidas working while the synthesis runs. Yeah, let's make sure the ports are happy and no one's upset about the ports. Ooh, okay. Okay, that's fine, it's fine. Go to IO planning. The pixel clock. Did that not get set to, that should be 33. Those are 33. Green 0 did you not get it signed properly? You're signed fine. So we should go double check on green 0. Oh, you didn't make it in there. That's fine. And then pixel clock 0 seems to have a issue with the else. Oh, there's no 0 in pixel clock, so that's the issue. Reload. Okay. Okay, IO ports are all happy. Cool. We'll keep that. But before, let's export the hardware so we can start working on a Vidas project, the pre-synthesis. Yeah, sounds good. Finish. Let's get Vidas up and running, and we'll copy over the software. So tools, launch Vidas 8 IDE. This is done launching. We will get the bitstream up and going. Okay. Okay, we'll worry about that later. Let's get the bitstream up and running. Okay. Oh. How do I turn it off? Is that somewhere in here? Ooh. Ugh. Why? Um. Just. How would you do this? Why? Let's just go. Let's just try a trick real quick, because I probably might have to call it quit. This is just getting to a kind of annoying stage right now. But let's see, where are we real quick? cd c/exep /au25p. Let's write a BD tickle real quick of just a simple simple VDMA.xdc. We're gonna need those commands that we ran ages ago. Where's add repository? Let's just go to the IP catalog, I guess, and delete one. So we'll remove that one. And add a repository. So cool. Let's go and look at those. Go look at that file real quick. AEU25P. Oh, I should rename it. Whatever. Fine. Yeah, before we do these, need to we're gonna set property to these guys. Okay, file, close project, file, close project. We're going to source that ugly simple XMA. Yeah, okay, I need to fix the board parts. Okay, it looks like we're gonna have to fix the board parts that need to be reset or something like that. Okay, so we're gonna have to end the stream and